So we're going to finish off chapter 6 by going back to the second part of chapter 6, because I did section 1, then section 3, now back to section 2, which is motion in a resistive medium. Now, what do I mean by resistive medium? That means we're moving along and it's resisting the motion. Well, that sounds very much like friction. You know, we have an object sliding along a rough surface and there's friction. Well, in this case, the resistive force here R in a medium is actually not constant. Friction is going to be constant, but the motion in a resistive medium may not be constant. In fact, R could be some function of velocity, meaning the faster you go, the more the resistance. So this would be, for example, air resistance or viscosity or something like that. So let's do a quick example. So we've got, let's say that we've got a small ball or something, or actually a big ball, 0.5 kilograms. So we have a chunk of something here, and it's sitting in a viscous medium, and we drop it. Now, if it's in air, you know it falls, you know, mg, so the acceleration is g. Well, in this material, it falls, but there's resistance to the motion. In other words, the material is compressing in front of it, it has to go around it, and so that exerts an upward force. That resistive force, let's say, is equal to 0.12 kilograms second per meter squared times v cubed. Okay. And so what happens is, if v is 0, the resistive force is 0, and the downward acceleration is g. But as v gets bigger, the resistive force increases. So mg minus r equals ma. So as v gets bigger, the resistive force gets bigger. Eventually, if R equals mg, then that means ma is 0. So that means the acceleration is 0. So what happens if the acceleration is 0? Well, it does not mean it stops sinking. What it means is that it reaches what we call terminal velocity, and that is the acceleration quits changing. Because if it stopped moving, then R would go back to 0 and start falling again. So this would be, for example, when the Titanic sank below the waves, then it got faster and faster, but eventually the resistance to the water made it fall at constant speed from that point all the way down to the ocean floor. So what I want to know for this problem right here is, what is the terminal velocity? Well, the terminal velocity is when mg minus the resistive force is 0. Okay, so at that point it's terminal velocity. So that means the resistive force has to equal mg. So 0.12 kilograms second per meter, actually meter cubed, I guess, per meter cubed times v cubed has to equal mg. Well, m is 0.5 kilogram, g 9.81 meter per second squared. So we can solve here. This is going to be the cube root of mg divided by 0.12 kilograms second per meter cubed. And so v comes out to be 3.44 meters per second. So that would be the terminal velocity for that particular problem. Okay, so